So what we're looking at today is properties of logarithmic functions. Now there's three main products that we have here. The first one's our product property, the second one is our quotient, and the third one is our power property. So the product property states that if we have two things multiplied together inside a logarithm, then it is the same as those two being added together. Our quotient property states that if we have two things being divided inside a logarithm, it is the same as those being subtracted from each other. And if we have something to a power inside a log, we can move that exponent out front. So these three here are our basic properties of logarithms that we have. And really one can be derived from the other. Because if we start off with the product property, if I have more than one thing multiplied inside the logarithm, we can rewrite it as addition of each of those logs. If we know that's true, we can actually show that the power property actually works from our product property. Because when we put something to the n, really we're just saying that m is being multiplied by itself n times, because we continue to multiply by itself n number of times, which according to our product property is the same as saying log base b of m plus log base b of m plus log base b of m, and we have it in times, because we're just adding it to itself multiple times over, which ends up being the same as n times, don't need a t, n times log base b of m, which is our product, or our power property, that we can bring that exponent out front. And both of these here actually work together to show that the quotient product is true. Because if we have m divided by n, well, what we could do is we could rewrite this as them being multiplied together, because I can move a variable from the numerator to the denominator or denominator to the numerator. It just makes the exponent negative, which says here would be the same as log base b of m plus log base b of n to the negative 1. And if we move that exponent out front, it turns it from addition to subtraction. So really these three properties, really from the first one, our product property, we can get the power property. And from our product in power, we can get the quotient. And what we're going to be doing today is kind of using these properties together and seeing how they work. And one other interesting one that we have, and this is not in your notes, is talking about log of 1. Well, what is log of 1? You can plug it in the calculator and see. It is 0. How about the natural log of 1? It's 0. Because what we're saying here is if we were to solve this using these here, well, it would be b to the x is equal to 1. Well, the only way for this to work, no matter what the base is if x is 0, because anything to the 0 power is 1. So really, what's kind of nice is anytime we have the natural log or log of 1, it doesn't matter what the base is, it will always be 0. That's kind of a nice property. Now let's look at these here. So what they want us to do is they want us to simplify or evaluate each of these logarithms given log base 2 of 3 is 1.585 and log base 2 of 7 is 2.807. So if we're not plugging these into the calculators and we're purely using these properties, we can actually solve these. Now, when we look at this here, we have 3 divided by 7 in the logarithm. So since I have 2 things being divided inside the logarithm, I can rewrite it as subtraction. Because we can rewrite log base 2 of 3, or log base 2 of 3/7 as log base 2 of 3 minus log base 2 of 7.
Is 3 minus log 2 of 7 written as an exponent, or is it just?
Log base 2, no, it's not an exponent, it's just going to be inside the log. So our overall base is 2, and 3 is inside the logarithm. Now, log base 2 of 3 is 1.585. Log base 2 of 7 is 2.807, which at this point here, we can plug this in to a calculator and figure out our answer, which would be I think it should be negative 1.222. And that is our answer there. Now with these here, you could have typed log base 2 of 3/7 because the graphing calculator, we went over that on Friday, can do that. And it should give you something close to this here. Get about the same thing. Yep. So either way works. So let's look at this next one here. We're going to use the properties for this. So we could type this into the calculator, but we're going to use the properties of logarithms to solve this. So we want to try to rewrite 21 using 3 and 7. So how could I write 21 using 3 and 7? We can rewrite it as what? Because 3 times 7 is 21. So we can replace 21 with 3 times 7. Because I have 2 things being multiplied inside the logarithm, we can split them up and rewrite them as addition. Because of our properties of logarithms, we can rewrite this as addition. 3 times 7 inside the logarithm can be rewritten as log base 2 of 3 plus log base 2 of 7. Now log base 2 of 3 we said is 1.585. Bless you. And log base 2 of 7 is 2.807. And now that we found these here, all we need to do is add them together. And this here would be our answer. Any questions on this here? Any questions on anything we've done so far? Let's look at this one here. So we have log base 2 of 49. So we want to rewrite 49 either using 3 or 7, or using both. So how can we rewrite 49 using 3 and 7? $49 would be the same as what? 7 and 7, or 7 squared, because either one works. We'd get the same thing. Because if we use 7 squared, well, I can move the 2 out front, which would give me 2 log base 2 of 7, which is 2 times 2.807, which would be 5.0 614? Do we agree with that there? So we didn't actually have to use the 3 for this here. So the log base 2 of 3, well, since 749 can be written as 7 squared, we actually don't need it. So they gave it to 7. Mm-hmm. So we might not have to use both of them. We could use at least one. Or we could end up using them to find a number that's not given. So 12, if we wanted to use, find, if they told us log base 2 of 4 is a number, log base 2 of 12 is a number, we can use the combination to find log base 2 of 3. As using multiples and working it out. Because, I'll add it here. Because if they gave us log base 2 of 4, we'll say equals x, and log base 2 of 12 equals y, well, log base 2 of 12 is the same as log base 2 of 3 times 4, which would be log base 2 of 3 plus log base 2 of 4. Well, they told us log base 2 of 12 was y is equal to log base 2 of 3 plus x, and we can use it to solve that way. Does that kind of make sense? Really, it's just manipulating the numbers to get what we want. Are there any other questions on these here? Do we feel kind of comfortable solving these and breaking these down? Yes? Okay. Well, if we feel comfortable with these here, we'll just move on to expanding a logarithmic expression. Now, when we expand a logarithmic expression, we want everything that's inside of the logarithm to be to the first power, and we don't want more than one thing inside the log. So that means when we get done with this here, we're going to have the natural log of 5, the natural log of x, and the natural log of y. We don't want anything else inside the log with them. So when we do this here, we're going to go in a certain order. We're going to start off with division first, then multiplication, then powers. And we're normally going to go in that order. So when we look at this here, so we have the natural log of 5x to the 7th divided by y. And we want to start out with the division first. So we could rewrite this as the natural log of what? 5x to the 7th minus the natural log of y. Because the numerator is being divided by the denominator. Numerator goes in one, denominator goes in the other, and we have a subtraction in the middle. Any other questions on this here so far? Okay, well, we don't have any more division taking place, but we do have multiplication because we have 5x to the 7th. Because the second one we want to use is multiplication. So we'll need to split those apart. And we can do that by rewriting them as addition. So we can split the 5 and the x to the 7th apart by rewriting them using addition. Because the natural log of 5x to the 7th is the same as the natural log of 5 plus the natural log of x to the 7th. Any questions on any of this here? Do we have any more multiplication going on at this point? Do we have any powers to take care of? Well, yes. So the x to the 7th, we can move the 7 out front. So a natural log of 5 plus 7 natural log of x minus the natural log of y. Yes? I have no idea. It really doesn't make sense why they did it that way. And really, the natural log is logarithms, log. It's just that the base is understood to be the irrational number e. Maybe, or it could be something to do with the roots of the word, where it came from, because it could be coming from the Latin or the Greek or whatever roots, depending on who was given the notation of this here. Because the same thing is true with slope, montane, or kind of M is slope, but we call slope S. Slope starts with S. And the best understanding I know for that is that it comes from the Latin or Greek word montane, meaning rise, where we get our word for mountain, which is M. So that's why we have the slope M, because it comes from that origin. So it could be partially due to just the origin of the words and how they came about, or the fact that it could be some languages have subject first, or kind of a flip. So for them, it could be logarithm natural. So it could be a flip and change. So it could be several things like that there. But I have not researched or looked into it enough to know for certain. So any questions on how we got to this point? Now, some of these here, these properties of logs do sometimes show up on the ACT, splitting these up or putting them back together. Not often, but they are something that they will pull from. So when we look at this here, expand the natural log of 3x to the 5th divided by y. So we always want to start out with division, simplifying the division. So how would we rewrite this? Yep. Natural log of 3x to the 5th minus the natural log of y. Because we can rewrite that division inside of the logarithm as this here. Do we have any other division taking place? Well, no, because it was just those two. But do we have any multiplication? Well, yes, we have 3 times x to the 5th, and we can rewrite it using addition. So we can split up 3x to the 5th to the natural log of 3 plus the natural log of x to the 5th. Anything else we can do? We can move the 5 out front, which would be ln of 3, plus 5 ln of x minus ln of y. And that is as simplified as this gets. We can't get this any simplifier than this. Simplified than what we have here. Because 3 is by itself, and that's as small as it'll go. X is by itself, and y is by itself. So that's all that we have for this here.
I need Victoria down to the office.
Any other questions on this here? We feel good with this here? Yes? Let's look at number 6. Because number 6 is a little bit different than what we've encountered so far. What makes it different than the last few? It's a fraction. But we have what? We have x. We have 2 things on bottom, yes? So our steps are not going to be any real different, because when we look at this here, we'll do the division first. We'd have ln of 5 minus ln of 12x. Now, at this point here, we do have multiplication, yes? Because we have the 12 times x. Well, this can be rewritten as ln of 12 plus ln of x, because those two can be rewritten as addition. But one thing we need to be careful with is the negative. is that negative, because both of them are in the denominator, so that negative needs to be applied to both of them. So we can rewrite it as this here, ln of 5 minus parentheses ln of 12 plus ln of x in parentheses. Or we can distribute that negative through to both of these here, which would be the same as ln of 5 minus ln of 12 minus ln of x. Because these would be the same thing, but we just have it written in a different way. Any other questions on this here? Yeah, we would do the log instead of ln. So how would we, what's the first thing we can do in rewriting this?
Log 6 of 3 plus log 6 of x.
Because the first thing we can do is rewrite that multiplication inside the log as addition of two logs. And then we can move that exponent out front. So we can move the 4 out front, giving us log base 6 of 3 plus 4 times log base 6 of x. Bless you. Thank you. So are there any other questions on this here expanding, on how we expand this out? Okay. Now the other direction we can go is condensing, bringing everything back together. So we can expand it out so every term is simplified, and then we can put it back together. Now when we're putting them back together, I really have thought through this and tried to figure out the best way to do it. And we're really just going to focus on powers and multiplication, our product property. We won't really have to focus on the division property if we treat the power property in a certain way. And what I mean by that is when we simplify this here, we want to simplify powers first and then do multiplication. And we won't have to deal with division. Because what I'm going to do, and the way that I think the best way to approach this is anytime we have a negative show up, which would be considered division, because when we have 2 subtracting, it's the same as dividing, I want to treat that negative as an exponent. Because there's nothing that says that we can't pull the -1 up into an exponent. Because as we saw at the start when I was showing the product, that we can use power and product to show division, I was just moving the variable or the number inside the log from the numerator to the denominator, is essentially what we can do, and it helps us out, especially if there's more than one term with a subtraction. It helps us keep track of how we actually need to divide. So when we look at this here, we want to start off with our power, or our exponents. Well, log of 9 doesn't have an exponent with it. There's not a number in front that we can rewrite as an exponent besides 1, and using 1 doesn't actually change anything. But our middle one, 3 log of 2, well, we can move the 3 back up into an exponent, which gives us log of 2 to the 3rd. And the last one we have is minus log of 3. And we can pull that negative up, which would just give us plus log of 3 to the -1. Because we pulled the negative up into the exponent, it becomes positive. Any questions on this here? So by pulling those negatives up with negatives up into the exponent, what we've done is we've gotten rid of any of the division that we have to pay attention for or look out for in our properties. And now it's all multiplication. So really we have log of 9 times 2 to the 3rd times 3 to the -1. And again, when we condense this, the bases have to be the same. Because these here, the bases are not written, they are common logs. All the bases are understood to be 10, so we can use this property here. The bases have to be the same. Now at this point here, if we wanted to type into the calculator 9 times 2 to the third times 3 to the negative 1, it would give us an answer, because they're all numbers. Now what I do know, if we were doing this by hand, well, 3 to the negative 1, to get that exponent to be positive, we would move it from the numerator to the denominator. And on top we would have 9 times, well, 2 to the third is 8. Are we good with this here so far? Well, will 9 divide by 3 evenly? Oh yes, 9 divided by 3 is 3. So we'd have log of 3 times 8. Well, 3 times 8 is? And that is as condensed as we can get it. So log of 9 plus 3 log of 2 minus log of 3 is actually the same as log of 24. Which problems like these here are nice, especially if we're trying to check it, because log of 24 is a number. Because I can type that into the calculator and get a numerical answer, yes? So we could type that in and see what it is. And I can check it with log of 9 plus 3 log of 2 minus log of 3. Because I can also type that in. And if those two answers are the same, then we did the right steps. So it's one of those things that's very nice that I can actually check to see, is this the same as what we started with? Because if it is, that means we did the right steps in simplifying this here. Any questions on any of this so far? They agree? Right. It's kind of nice when the numbers work out that we can check them. So let's look at this one here. We want to condense log of 6 plus 4 log of 3 minus log of 3. Well, as we saw in the last one, well, log of 6, there's no powers to utilize. We can't utilize the power property because there's not a number in front of the log. But for log of 3, we can rewrite it as plus log of 3 to the 4th. Because we can move that 4 from out front up into the exponent. So we move the 4. Now we can also move the negative up into the exponent as well, which would give us plus log of 3 to the negative 1. Any questions on this here? Well, now we have 3 things being added together, so that would be the same as saying log of 6 times 3 to the 4th times 3 to the negative 1. Because when I have 3 logarithms with the same base added together, we can rewrite it as 1 logarithm with what's inside each of the logarithms being multiplied together. Now we can do the exact same steps that we did on the first one, the one we just did previously, and I can rewrite that 3 or move one of them to the denominator. But unlike the first one, do I have 2 things multiplied together with the same base? We have 3 to the 4 times 3 to the negative 1, yes? If the bases are the same and they're being multiplied, we can add the exponents. Because if I move the 3 down below, well, it will cancel with one of the 3's to the 4th. Or if I do
Austin, edits come to the office.
4 plus negative 1, well, 4 plus negative 1 is 3 to the 3rd. What? Yeah. No, because we could have also written this as log base 6 times 3 to the 4th over 3. Well, 3 to the 4th over 3 would simplify to 3 to the 3rd. It would be the same property. You can do it either way. Because this here will still come back here. Because that's why those two properties work so well. Because when we have like bases on top and bottom, we would subtract the exponents. So 4 minus 1 is 3. When like bases are being multiplied, we add them. 4 plus negative 1 is still 3. So it works either way. But last but not least, we still need to simplify 6 times 3 to the 3rd. Well, 3 to the 3rd is 27. So we would get log of 162, which would be the same as what we started with. Any questions on any of this here? We feel pretty comfortable with this here? Yes? And I feel like most of these here, because the rest of the examples we have aren't any real different than this here. Because this is pretty much the same thing we did, same thing we've done, and so are these here. Now, the reason I say that this exponent rule is nice for let's do 16. So I'm just making this one up here on the spot. Now, if we were actually to apply the division property, I would have to group the log of 2 and the log of 16 because they both have a negative in front of them. And then factor out that negative so that we can apply the division property and go from there. But because if we use the exponent property, well, this should just be log of 4 plus log of 2 to the negative 1 plus log of 12 plus log of 16 to the negative 1. What I've done is I've eliminated that step of trying to regroup everything that has a negative with it and rewritten it as an entire group of where we have addition, addition, and addition so that we can just use the product property. And I rewrote those in the different order, but we can still get this here. So it's a little bit easier so we're not trying to worry about how do we deal with fractions. And do we have fractions in fractions? And it makes it a little bit easier to work with, where then we can rewrite it as this here, 4 times 12 over 2 times 16. Well, 1, 6, 1, 4, 2, 3. So if we plugged it in, it would have been log of 3/2. But again, that's simplifying down 4 times 12 over 2 times 16 is not a huge deal. But any questions on any of this here? Now, the last thing we're going to go over is something called the change of base. Now, as we went over on Friday, we talked about, or kind of had y'all type in log of a certain number, which is slipping my mind at this point, but we saw that it didn't work out well. Because just the normal log button on the calculator, not log base, doesn't work unless the base is set at 10 as a common log. But we do have something called the change of base. If I have log base C of A, I could rewrite it as log base B of A divided by log base B of C. And when we do this, that B, that base, for what we're rewriting it as, is understood to be 10. We're wanting to change it to common logs. So that really we have log base C of A is equal to log of A divided by log of C. What's inside on top? What the base is on bottom. And it actually works out that it's the same as the natural logs. So it's a little bit easier to work with. In particular, if we have log base 3 of 8, and I want to rewrite this as common logs, we're going to use this property here. Log and log. So what number would go on top? Eight would go on top and 3 would go on bottom. So what's inside goes on top, the base goes on bottom. Okay, now how would this look if I wrote it with natural logs? Ln of 8 over Ln of 3. So this is handy to know, especially if you're having to try to evaluate logarithms with a calculator that does not have log base. So the yellow calculators. If I have one of those and I want to evaluate log base 3 of 8, well, I can split it up into log of 8 over log of 3, and it would give me the answer. So I don't have to go in to the graphing calculator, find log base to type this in. We can type it in as log of 8 over log of 3, and it'll actually give us the same thing. Questions on this here? Now the homework will ask you to evaluate this to 3 decimal places, so you just can type it in and it'll give you 3 decimal places. So let's do another one. Log base 7 of 11 would be what? Log of over or? And that's it. So if we want to use the net change of base, that's all we're doing for these here. Now we could go the other direction as long as the bases are the same. So I could go to this here. Oh. But I want you to realize something with this here. This is not the same as this here. Because our division property, if I have 2 things divided inside the log, I can rewrite it as subtraction. It does not work that 2 logs being divided is the same as our division or subtraction inside of the log. Because it's also not the same as log of 11 minus 7. It doesn't work that way. Because our division property only works if it's being divided inside the log itself. I think you all feel comfortable with these here, yes?